Shoot, Bodie! Pull the cord now! Nah, you pull it. 6 seconds. We're gonna be meat waffles. Go!
Hi everyone, our project is called Float or Crash, and today we're going to be analyzing the clip you just watched in the 1991 movie Point Break. So in the movie, we see two characters, Bodhi and Johnny Utah, jumping out of a plane as they fall in a matter of 8 seconds. The two characters fall together and appear to survive successfully in the clip. Our project aims to uncover whether or not Bodhi and Utah would actually survive and if the fall was realistic. We're first going to establish a reference frame, knowns, and equations. Then we'll describe the steps for analysis and give a conclusion whether this clip was an example of good physics or bad physics. Finally, we'll talk about the physics for the further analysis section. Over here, we have a list of all the givens. We know that it takes Utah and Bodhi 8 seconds from the time they deploy the parachute to when they land on the ground. The mass of each man is assumed to be 75 kilograms, so the net mass is 150 kilograms. The atmospheric density, rho, is 1.225 kilograms per meters cubed. The coefficient of drag quantifies the drag or the resistance of an object in a fluid environment, like air in this case, and that value is 0.75. And finally, we know the landing velocity to be 6 meters per second. So on the right, we have some equations that'll help us solve this problem. And over here on the bottom, we see a reference frame. So analysis. So to determine if this was realistic, we'll be determining the surface area of the parachute's canopy. Note that the larger the parachute surface area, the more area of pressurized air it'll be able to capture in the canopy, thus producing a much larger drag force. This would effectively make the object fall slower. We first find the terminal velocity of the two men. Solving for this velocity, we get 58.55 meters per second. Then we proceed to find the average acceleration of the fall, getting negative 6.57 meters per second squared. We use this value to find the force of drag, which is the same as the force due to gravity at terminal velocity. The faster the two men fall through the air will lead them to collide with more and more air molecules, thus making the magnitude of the drag force on the object larger and larger until the drag force is equal to the force due to gravity. Using Newton's second law of motion and taking the absolute value, 150 times negative 6.57, we get the drag force to be 985.95 newtons. Finally, we can calculate the area of the parachute and get an area of 59.62 meters squared or 641.74 feet squared. Note that the parachute's canopy area is the area required for the two men to land safely on the ground at a velocity of 6 meters per second. So, is this good physics or bad physics? Well, the average size of the expert parachute is around 80 feet squared to 200 feet squared, but the estimated area of the parachute for a safe landing is 641.74 feet squared. So this may seem fine at first glance, but it's not for several reasons. First off, using a parachute with a canopy surface area that large in relation to the weight of the men would cause something called wing load. And basically this means that the larger surface area would imply a greater wing load, and canopies with huge wing loads are susceptible to wind turbulence and crosswind. So in order for Bodhi and Johnny Utah to land safely, they would need a 221% increase in the size of their parachute.
When looking at the total amount of energy that the parachute converted, we're able to find that by subtracting the total amount of gravitational potential energy by the final kinetic energy. We do this by multiplying 150 times 9.8 times 3,657.6 to find the total gravitational potential energy, and we subtract that by 1 half times 150 times 6 squared to find the final kinetic energy. And in the end, we get 5,373,972 joules, which is the total amount of energy which the parachute converted. So when looking at the actual movie, obviously this wouldn't have never actually happened in real life. Both Bodhi and Johnny Utah would have died. But there's some things that the cast could have done to make this more realistic. So the first thing that they could have done is reduce the weight. So let's assume that the movie was different and Johnny Utah somehow find a way to take the parachute off of Bodhi while they're skydiving and put it on. Well, all of a sudden, Bodhi is not part of the weight anymore. So our weight gets divided by 2. So the 150 turns into 75. And then all of a sudden, our area for the parachute turns to 79.8 meters squared or 320.73 feet squared. Now, this is not in our realistic range of 80 to 200 feet squared for an actual parachute canopy, but there's still some things that we can do. The cast could have also done another thing. They could have had Johnny Utah fall in water. Water, of course, is way more compressible than the rocks that they fell on. So falling in water would be so much better because they're able to fall at a higher speed. The fatal speed of hitting water is 60 miles an hour or 26.82 meters a second. So what we're able to do is put in a realistic value for our canopy, 140 square feet, and multiply that by 0.09 to convert it to meters. But instead, now we can work backwards to find what the velocity would be. We can find that our final velocity is 8.83 meters a second, meaning that Johnny Utah would have 100% survived because this 8.83 meters a second is nowhere near the 26.83 meters a second, which is the fatal speed of hitting water. This means that if Johnny Utah had taken the parachute and landed in water, this scene in this movie, Point Break, could have actually been real.